So far we've been looking into one or two variables at the same time, but many times we're going to be interested in looking into more variables, three, four, maybe even more than that. Things like we see that there might be a possible effect of a third variable, like we saw, these different clusters of data. We need to show even more than two. How do we do it? We have essentially two options. The first of them is faceting. And what we do here is divide the data set in different groups according to one categorical variable. It could also be numerical if we just break in different ranges, but normally it's a categorical one. And what we do is make the same plot for each of those sub data sets, for each of those groups of data. And in doing so, we might reveal patterns that do not appear at the group level when we see at the whole data set, but they do appear when we look down into the level of each of those groups, or maybe the other way around. Or maybe we see a positive relationship in the whole data set, but if we look into, for example, neighborhoods, the relationship turns out to be negative. But it's a good idea, again, to plot something specific, but divide it in different categories and make the same plot so that we see whether all the plots look kind of the same or if there are differences across the categories. So when to facet is going to be evident when we look at a certain plot and we see that there might be something going on beyond the two variables that are being displayed. Something like clusters, many outliers in some points, etc., etc. Which variable should you facet across? Well, it depends on the problem you're looking into. Normally, you're going to require to have some sort of domain knowledge to at least get a hint into which might be the variable or variables that are responsible for these patterns in the data. Let me show you an example. So here we have the distribution of the prices in the listings by room type. Yeah, nothing out of the ordinary. We also have here the distribution by neighborhoods. So something we see here at the level of the whole data set is that we see this price increasing, right? Entire homes are more expensive than private rooms and shared rooms. And we have here which neighborhoods are more expensive. One might wonder, is this pattern relating to the room types consistent within the neighborhoods? So are entire homes, apartments more expensive than private rooms in all the neighborhoods? Perhaps they aren't. So let's take a look. So here we are faceting, and essentially we have one panel per neighborhood. Again, in the x-axis we have the price, in the y-axis we have the room type. We're again looking at box plots, but only the data corresponding to each of the neighborhoods. And sure enough, we have three neighborhoods that don't behave like the others. So in this case, we have that the shared rooms are by far the most expensive, and that's weird. That might be telling us something's going on in there. In here, we have also shared rooms that are more expensive than private rooms. That's also weird. And in here, kind of the same story. Shared rooms are even more expensive. So here, thanks to faceting, which is, again, just choose one variable, in this case, the neighborhood, to see whether patterns or relationships that we see between room type and price hold at the level of the neighborhood. And we see they don't. And knowing this might be leading us into new investigations or realizing that we have a just small mistake here in the data. It should not be, €1,000. It should be 100. What other things could we say? Like in here, we know from a previous video that there's this relationship between the price of the diamond and the carat. It's this non-linear relationship. It's positive, but we saw that we had these kind of clusters of points, right? And we also saw, thanks to transparency, that it's actually a lot of points around 2, a lot of points around 1.5, 1, etc., etc. What could be the reason? Well, let's look into facets. What facets can we look into? So in this case, we're going to look into the clarity and the cut of the diamonds. So over the rows, we have the cut. So the cut is anywhere from fair to ideal. So down here at the bottom, we have the best cuts, and the columns correspond to the clarity. So we go from low clarity over here to very high clarity over there. And then immediately we see relationships, right? We see things that change by cut or by clarity. The relationship between price and cut changes. So yeah, it's something like this in general, this non-linear kind of opening up relationship. But we see that across the rows, so that means across cuts, if you look into any specific column, so if you look into any specific clarity, the relationship is kind of the same. So what matters is the clarity. Once you are in a certain clarity group, it doesn't matter which quality of cut you have. The relationship is kind of the same. However, if we do it the other way around, there is change. So if we have a certain quality of cut, then depending on the clarity, you're going to pay more or less. And so what we see here is that, for example, for cuts that are very good, if you don't have much clarity, then there's this kind of linear relationship between the cut and the price. But as you get more and more and more quality in terms of the clarity, you see that the relationship becomes more and more and more steeper, such that if you have a clarity that is very high, IF, the price increases a lot faster with respect to the carat than in the other categories. So this is a relationship between carat and price that depends to a certain degree on the clarity. This is something that we will talk about in the coming lectures when we talk about interaction effects, moderating factors. But again, it's something that just by faceting, which is something very easy to do with a computer, we are going to be able to see very, very easily. And for example, we also see that there's no points around there. And those would be diamonds that have a very good clarity but very low quality cut. So who would buy those diamonds, essentially? No one. Now, the other option, besides faceting, is just using different graphical aesthetics. So try to take the plot kind of to the next level. So we might incorporate different graphical dimensions, different aesthetics. Think, for example, of the color. In a scatter plot, we might use green for one category, pink for another category, blue for another category, etc., etc. It's just different colors for different categories, and then you just make the scatter plot, and that's it. You're going to see different groups of observations, perhaps identified by the colors, and then this is telling you that there is a very clear relationship between the variable used in the color and the others. If it's a numerical variable instead of categorical variable, then normally what we have is a different gradation of the color. So something like going for light blue or dark blue, depending on whether you have low values or high values in your variable. Think, for example, of the point size. In a scatter plot, you could have points this big or this big or this big. Just make the size of the point proportional to another variable. Or if you're showing lines, you can make them thicker. So depending on the values of a numerical variable, you can make the points or the lines bigger or thicker. And that's, again, maybe showing you another relationship. If your other variable is categorical, you can think, for example, of different shapes. So instead of making every observation just a circle, you could make some of them squares or triangles or diamonds, crosses, whatnot. The point is you represent each observation with a different shape depending on the category they have in another categorical variable. And of course, the line type. It could be a solid line, a dashed line, a dash, dot, dash, etc., for different categories. And the thing is, we can play with all these different graphical aesthetics, no problem. There might be showing us another relationship between the main variables in our plot and a third variable or a fifth variable. And And so far, we've been using two graphical aesthetics, the position along the x and the y-axis. So numerical variables are suitable for color and size scales very well. Just try to play around with different colors, different shades of blue, different sizes of the points, etc., because that might tell you something. So for instance, here we have this scatter plot of x and y dimensions of the diamond. Uh, we couldn't see anything, right? Even if we were using some transparency in there. Something that we could try is uh, use the color for the price. And what we see is that, sure, bigger diamonds have bigger prices, right? But it's not so clear. So it's like we have these two separate clusters of data, right? There might be something else going on. Maybe there is something going on with the clarity. Or maybe this visualization is still very bad and we need even more transparency because it's just a lot of dark in here that might correspond to many light observations. Here we have, again, the relationship between carat and price. And if we add a categorical variable for the color, in this case, the clarity, we see very clearly the relationship we saw earlier on with the facets, that low clarities over here, they correspond normally to low carats. And so we have more purple over there, blues, greens, oranges, right? That's something that we may be capable of seeing very easily here when we use another aesthetic, the color. And we can add more than two. So for example, in this case, we're seeing the number of observations, the neighborhood, the room type, and the price. So we have four variables in the same plot. And what we see is that the size of the plot, the size of the point corresponds to the number of observations in the specific combination of neighborhood and room type, and the color corresponds to the price. So in general, we see that there are many observations around here, right? That's very easy to see. And yeah, entire homes tend to be more red than private rooms. Everything is clear. We see different shades of green and red over there. So there's more variation within entire homes than there is within private rooms. And of course, the very weird observations in there. Everything is green except for those two that are red. Something's going on in there. And this is something that we may be able to see very easily again because we add more aesthetics. We see that, yeah, there's something going on, but according to the size, it might be just 1, 2, 3 observations. Maybe we don't care about those. And as a final example, we have here again the geographical distribution of all the listings in Berlin. We have the contour plot, right? So we have many observations around there, there, and there. If we start adding aesthetics, we see, for example, with the color, the price, and with a different shape, we have the room types. So we might be able to see that over here, these very light green points are actually squares, so they are shared rooms. And in some cases, we may see red spots over here that are a triangle. That could mean there's a private room, very expensive, somewhere over there. That might be telling us something.